Assalamu alaikum. I am Tahir from Department of Computer Science, Allama Iqbal Open University. We are discussing unit number 4, entity relationship diagram, second part. In first part, we discussed the initial topics, and in the second part, we start from one-to-one relationship. A one-to-one relationship means that only one instance of an entity can be associated with only one instance of another entity through that relationship. For example, in a university database, each student may be assigned a single course. Each student may be assigned a single teacher for a single course. Another example is an employee and a passport one. Employee has one passport and each passport is linked to one employee. In entity relationship diagrams, this relationship is represented by placing one on both sides of the relationship line. So remember, in a one-to-one relationship, entities are connected with each other with a single instance. This type of relationship means that one instance of an entity can be associated with multiple instances of another entity. For example, in a university system, one instructor can teach many students, can teach many courses. So courses and students are many and teacher is one. So this association is called one-to-many. Another example is in a company, one department can have many employees, but each employee belongs to only one department. In entity relationship diagram, this is shown by writing 1 on one side and N or M on the other side of the relationship line. So M or N denotes for many relationship and 1 denotes for one relationship. So whenever you see a one-to-many relationship, think of it with respect to that database. In the left side, there is a single entity, and at the right side, there are many entities. So if from left side, we denote this with a teacher, and right side, we are showing multiple entities of students or courses. Now let's discuss the many-to-one relationship, written as N-to-1 or M-to-1. This type of relationship is simply the reverse view of a one-to-many relationship. It means that many instances of one entity can be linked to a single instance of other entity. For example, in a company system, many employees can work in one department, or in a school, many students may be enrolled under one advisor. In entity relationship diagram, this is shown by placing N on one side and 1 on the other side of ER diagram. So whenever you see an N-to-1 relationship, remember, it's just another way of saying many entities point back to one single entity. The diagram shown here reflects a many-to-one relationship. As you can see, there are multiple instances of entity on the left that can be connected to relationship, but they all point to only one instance of the entity on the right side. For example, in a university system, many students can be assigned to one advisor. Similarly, in a company, many employees may belong to one department. So this image clearly depicts a many-to-one relationship, where several entities on one side are linked back to just one entity of the other side. The diagram here reflects a many-to-many relationship, written as M-to-N. This means that more than one instance of the entity on the left can be associated with the relationship, and at the same time, more than one on the right side. For example, in a university database, many students can enroll in many courses, and each course can have many students. Similarly, in a retail system, many products can be supplied by many suppliers. So this image clearly depicts a many-to-many relationship. As shown in the diagram, there are two different entities. One entity is customer and the second one is loan. Customer borrows loan from the other side, maybe that's a bank or other activity. So customer, there are multiple characteristics of customer. Customer, there may be different names for description. There may be customer IDs for differentiation, their addresses, and many more. Maybe they are common. They are common customers are specific. So at the other side, loan have multiple attributes: loan number, loan amount, loan type, and the loan given department. So we can describe these things by different attributes. And the third one is borrower. Borrower is basically a relationship. These are entities. That's borrower is a relationship. Loan is an entity, customer is an entity, and all others are basically attributes. So in this topic, there are three core things. One is entities, second is attributes, and third one is relationship. So in the next, the relationship set borrower may take different forms such as many to many, one to one, one to many, or many to one. To distinguish between these types in an entity relationship diagram, we use lines between the relationship set and the entity set. A directed line that has direction basically indicates that the relationship is one to one or many to one, showing that only one instance on that side can participate. An undirected or simple line indicates many to many or one to many relationship, showing that multiple instances of one side is relating to the other side. For example, if a borrower can take many loans but each loan belongs to only one borrower, we represent this with a directed line from loan to borrower. This notation helps us visually distinguish the cardinality. In the below diagram, again we are showing all these. Borrower to loan is basically directed line, and customer to borrower is basically undirected. As discussed earlier, these are two separate types of relationships. If the relationships at borrower were many to one from customer to loan, then this means many customers can participate, but each loan is given to one borrower. In the ER diagram, we show this is drawing a line from the relationship set borrower to the loan entity with an arrow pointing towards loan. This arrow clearly represents that for every loan there is one and only one customer, while on the customer side there may be multiple. If the relationship set borrower were one to one, then both sides of the relationships are restricted. This means each customer can be linked to at most one borrower, and each loan can be linked to at most one customer. In the ER diagram, this is shown by drawing arrows on both lines, connecting the relationship set borrower to the customer entity set and to the loan entity set. In this diagram, there is a borrower that's basically connected towards an entity loan and towards an entity customer. The relationship between borrower to loan is many, and the relationship between borrower to customer is one. There may be multiple loans that a customer can get, but a single customer may apply to the multiple loans, and these can also be distinguished with attributes given there. If the relationship set borrower were many to one from customer to loan, then this means many customers can participate, but each loan is given towards one customer. In the ER diagram, we show this by drawing a line from the relationship set borrower to the loan entity with an arrow pointing towards loan. This arrow clearly represents that for every loan there is only one customer, while on the customer side multiple loans can be applied. If the relationship set borrower were one to one, then both sides of the relationships are restricted. This means each customer can be linked to at most one loan. He or she can apply for single loan, and each loan can be linked to at most one customer. In the ER diagram, this is shown by drawing arrows on both lines, connecting the relationship set borrower to the customer entity set and to the loan entity set. As shown in the diagram, there is an entity customer. Customer have multiple attributes. Age is an attribute, date of birth is another attribute, address is another attribute, customer. So name has also multiple attributes, first name, last name, and single name. These attributes are basically called composite attributes. And in the right side, the attribute address has also multiple attributes. These are street, city, state, and zip. So that's also this attribute is also a composite attribute. There may be with street, maybe there are multiple streets, or there are multiple customers that live in a single street. So we can distinguish them with customer ID. And phone number have double olive. It's mean maybe there are multiple records. Any customer have multiple phones. And another example, there is an entity employee, another entity branch, and relationship is basically work on. The entity employee have employee ID, employee name, employee street, employee city, maybe employee phone, qualification, expertise, maybe multi more attributes. We can describe it with multiple attributes. The another entity branch means employees working in which branch. The branch name, if singular, one attribute, branch city, another attribute, the assets that branch have is maybe another attribute. So the third entity is job. Job have multiple attributes, job title, job label. So this relationship that have one employee can work in a single branch and should have a single job. So that this relationship is basically between all three is one to one. We can represent a database that conforms to an ER database schema by using a collection of tables. For each entity set, we create a unique table. The table is given the same name as the entity set or relationship set it represents. Each table is made up of columns, and every column has a unique name. Basically, we are converting entities towards tables. The attributes are columns. So there must be unique attributes that distinguish all the records. Records are values having a single relative records. This mapping from the ER model to relational tables is the key step in transforming our conceptual design into a working database. Both the entity relationship model and the relational database model are abstract and logical representations of real-world enterprises. They help us to describe how data is structured and how it is implemented. Since both models follow similar design principles, we can easily convert an ER design into a relational design. In practice, this means once we have drawn our ER diagram to capture the requirements, we can transform it into relational tables that can be implemented directly. Converting a database representation from an ER diagram to a table format is the standard way to move from conceptual design to relational database design. When we perform this conversion, every entity set becomes a table. The constraints defined in the ERD, such as primary key, foreign key, and cardinality constraints, are directly translated into table level constraints in the relational schema. This ensures that the structure and rules of the ERD are preserved in this. There is a schema as shown on the screen. There is an entity that's called customer, and their attributes: customer ID, customer name, customer address, customer city, customer state, customer zip code, and customer if applying discount. So that's called a schema of a single entity or a table. I am using two words for this: entity or table. Entity should represents a table in later stages. Entity is basically we are defining at the time of design, and at the time of implementation we are basically converting it to tables. In phase 1, transforming an entity to a relation, ER diagram. So in the second phase, transforming an entity to a relation or relational model. In this diagram, there is an entity customer, which have customer ID, customer name, customer address, its city, state, zip, and discount if applying. So this table have name customer. Its attribute, first attribute is customer ID. We convert it to a column of that table, and second one is name. We convert the second column of this, and the address, third column, city, state, zip is the fourth column, and discount is the fifth column. So basically we convert this entity to a working table. Finally, we saw how an entity relationship diagram can be converted into a relational table, preserving keys and constraints to form a proper relational database design. The ER model is powerful because it allows us to move from the conceptual level where we think in terms of people, objects, and activities down to the implementation level. Thank you. That's enough for today. In the next lecture, we will discuss the implementation of the database. Allah Hafiz.